Hello! In the previous video I did some work with remote controls, transforming them into something that makes sound. And I also mentioned the possibility of using one of those.
How cool is that?
So this is an infrared remote for a radio cassette, and I've taken this apart already, of course. And there is some magic happening here, you will see. So I have this little speaker. You don't use any kind of good speakers for these experiments, you know. And then I'll just connect the ground to the negative battery terminal, you know, 3 volt. And now I'll connect the crocodile to the hot side of the audio, and then push some knobs. These knobs are quite sensitive, so if I just lick my finger, the humidity is enough. Now I push the button, and just touching the hot completes the circuit, and the volume leads to the pressure, so the resistance becomes less. And they all make different sounds. It's amazing. So let's use something else. I don't know, whatever. I just have this iron thing. And you know, you see this transistor thing, changes the pitch. It's amazing. Yeah. How about that? So right, we have this thing that makes these noises by touching these areas of the surface, and then we should have another surface to touch that's responsible for the volume of the output, and then we have another thing to touch here that glides the pitch down. So how should I work with this? Although in the beginning I was thinking to take this out of the housing and make it do something totally different as a form factor, I ended up keeping this because, you know, it has this window, and this we don't need because triggering like that, pushing the buttons, is not reliable. It doesn't make that product. Well, it wasn't working even when it was together, so for that reason this material deteriorates after a couple of years. So I think I'll just do it like that with my finger, and maybe here have some control aspect. But then, you know, it dawned on me that I could use this. Yes, this is SuperVHS tape, and you see the spool. And it has the amazing property, electrical resistance, that is related to the distance. So it conducts electricity, but it presents about, you see, 15-16 kilo ohms. I don't know if you can see. 10 it is now. Well, it depends very much on the type of contact between my probes and the tape, but well, say 10 kilo ohm per centimeter, and it's not really, it's not linear at all. So you see 2 centimeters is 16, not 20, and if you go like 10 centimeters, 10 is here. Is about half, 58. It's about 100. It's about 100 kilo ohm per 20 centimeters. So I want to use this material for all the touch surfaces. So I'm gonna suspend like rows of it, not rows, columns, like that to simulate the button presses. And then I'll have some like glued here at the side. Depending on where you touch, that will be louder or quieter. And maybe have here the pitch control or on the other side. But it all depends on how you're gonna hold it. So I made this frame out of cardboard to hold the strips of tape and fix them in place with hot glue. So they can be suspended over the contacts for the buttons on the PCB. And also I removed the infrared LED that I didn't need to make space for a mini jack socket from an old circuit. You can see how it comes together. I made these notches to hold the frame within the plastic casing, so the strips can be suspended over the PCB without touching and allowing the hand to glide. And the socket just fits in that space. I was testing to see how it all feels to decide where I put the strips. And I carved the hole to make the socket fit. And here you see I used a piece of copper foil which would be connected to the hot of the socket, and I would touch that with my finger to make the connection. And here is the finished product. There is tape which is connected to the copper for the connection to the hot, so influencing the volume, and on the lower part connected to the pitch point on the PCB to control the pitch. Rubber bands holding the case together, which like after opening and closing so many times wouldn't stay together. There are no screws, this thing is press fit. I ended up putting SuperVHS tape all around so I can hold it with either hand. It's quite chaotic, but it can be very expressive. You see, when I press the buttons, it doesn't sound. I have to actually press on the side. Right, after all that I felt comfortable to try it through my good studio monitors, passing through the filter of Monotron Duo. The pitch control is very sensitive, so it's quite difficult to control it precisely. Some more work would be needed for that, but anyway. And then, of course, why not through a much larger synthesizer? It is the EMS Synthi100 at the Contemporary Music Research Center in Athens, and I'm driving the dry signal through a low-pass filter. Here you see I'm adjusting the frequency. And I'm also sending the signal through an envelope follower that controls the frequency of that filter, but also through a pitch-to-voltage converter that controls the frequencies of 3 oscillators that are mixed together into a different output channel. And I can mix the dry signal together with the signal from the oscillators. I'm also using the second envelope follower to control the release of an envelope that is being triggered by the signal itself. So I mean, I'm trying to use the device as a controller for the synth. All sorts of different patches could be created. Λίγο να πάει. And here are the patch matrices for what it's worth. I'm also using the ring modulator, I think. And here you see envelope triggering by the device, the followers. And well, patching possibilities are practically endless.
Είναι τηλεκοντρόλ για κασετόφωνο.
A nice little toy. Well, I don't know how useful it might be musically. Seems like it has some potential, and it's very easy to make, and it's for free basically. Lots of those remotes hanging around and destined for the trash bin, so I might make a couple more. and I might try to make them into modules instead of handheld devices. Well, we'll see. Thanks for watching. See you next time.